Now that we've talked about the concepts behind spanning tree protocol, let's get it set up. We're going to take a look, first off, at our new network diagram. We're going to enhance what our network diagram looks like, add some redundant connections. Then we'll look at the current spanning tree protocol configuration. Because it's already running on all Cisco devices, let's see how it ran by default. Then we'll tweak it, we'll tune it, we'll make it more efficient, and then we'll do some tests. I'm going to do some ping tests and pull some links and see what happens and how long spanning tree takes to fail over. Now, before we get going into the material, I have to show you something. I have to show you this most amazing, coolest thing I've ever owned in my life. You may have heard of the Apple iPhone, right? Well, I got one, and you got to see it. You got to see this picture I just took of it. It is the biggest waste of time I have ever had, but I love it, and I can't stop using it. Look at what I'm doing. This is an Apple iPhone, right? It is SSH'd into a Cisco firewall. Look at this. I went into privilege mode, enable. I typed in my password. I got into global config mode from my phone. Isn't that awesome? I could fix a network issue from a red light on the road, or a green light for that matter. Why not? So, anyway, this thing is great. I'm telling you. There's hundreds of programs for it, and you can get all kinds of like network sniffers for it. It's amazing. I haven't figured out how to connect a console cable to it yet, but that's my latest cool thing. Okay, let's talk about STP. So I've made some slight changes to this network diagram since the previous video. All I did for this configuring and testing spanning tree is move the PCs back out of their VLANs. Now don't worry, that's a temporary thing. This is just going to be the basic STP before we get into all the enhancements. And to do that, everything is just put back into VLAN 1. So you can see these two computers are out of their VLANs. They're assigned their normal VLAN 1 IP addresses. They are able to ping each other again. These VLANs are still there. They're just, I guess we could put a little not in use because everything is currently joining VLAN 1. Now, in order to set up redundancy, what I did was connect a crossover cable between switch 2 and switch 3 on fast Ethernet 0/24 on both of them. Now, what that does is create a redundant link, so if switch 1 goes down, switch 2 and switch 3 can still communicate, and the PCs can talk. They can still at least get across the WAN link and so on. They'll just lose connectivity to whatever switch 1 was connected to. But when I introduce that link into the picture, we now have a loop in the network. So spanning tree needs to jump in and block one of these connections. But before we can determine which one it's going to block, we have to telnet in and do some show commands to find out who the root bridge is. So let's do that. I'm going to take you to the let's just start on switch 1. That's our core switch. So I'll take you to switch 1 and type in the show command. You can just type this in from any switch that's running spanning tree. Just type in show spanning tree. You could also type that from your Apple iPhone if you wanted to. All right, I'll stop. You can see I'm going to stop the output right there. You can see we have VLAN 1 running right now, and it gives some information about spanning tree. It says spanning tree is enabled, protocol IEEE, meaning it's industry standard. Underneath here, you'll see it divided into two sections, root ID and bridge ID. This right here is the information about the root, meaning the root switch currently has the priority 32,769. It currently has the MAC address 008, there's the MAC address. It currently costs 19 to reach the root bridge, and I'm going out port fast Ethernet 0/11 to get there. As a matter of fact, if you glance down at our interfaces, you can see fast Ethernet 0/11 is designated as the root port. Okay. So all of this information right here is information about the root bridge. This is information about switch 1, the switch that you're currently on. You can see the bridge ID is this. The MAC address is this. The hello time, meaning how often is it saying hello and checking the spanning tree topology. This is actually how often it's sending out BPDUs to say, hey, is there a loop in the network? Once every 2 seconds. Because to a switch, that's not a problem. There's tons of bandwidth to use. So it's always checking to see if there's a new loop in the network. So this is the divide between the two. Now you might remember that I said the default priority on every switch is 32,768. That was from the previous video when we talked about the concepts. Now, Cisco switches run a special version of spanning tree we're going to talk about in the enhancements called per VLAN spanning tree. So what it actually does to enhance it is add the VLAN number, they call it a system ID extension, to the priority, and so all the switches that are in VLAN 1 have 32,769 as their priority. If you were in VLAN 10, you would have 32,778, which would be the priority plus 10 more. So it always adds the VLAN number, but it's the same thing. All the switches are tied on their priority, so it's using the MAC address to find out to break the tie and determine the root bridge. So while it's all fine and dandy that this has told us, hey, this is the root bridge, I mean, how do you know who has that MAC address? Well, it's time to trace some cables. You look at your network diagram and find out on switch 1, what does port 11 or Fast Ethernet 0/11 connect to? Jump back here. Fast Ethernet 0/11 connects to switch 2. So chances are, if you follow that link, you're going to find the root bridge. And as a matter of fact, you can also notice right here, Fast Ethernet 0/12 is blocked. So that gives us a big clue, chunk, that link is disabled because that is the least efficient connection. So the two active links right now are these two. So you can kind of see and diagnose what spanning tree is doing. Now the problem is the 3550 is our core. We want that to be our root. It's the bigger switch. But switch 2 became the root just because it has an older MAC address, an older manufacturing date. So that's the one that is currently active right now as the root bridge. So, well, actually, let's jump on over to switch 2 and just verify from there. I'm going to type in show spanning tree on this switch. Look at that. VLAN 1 root ID, this is the root information, and it says right there, it's very blatant, this bridge is the root. You can look below and see that the MAC address of the bridge ID, which is this switch, matches the MAC address of the root ID because they're one and the same priority, same MAC address. Notice every single port is considered designated because the root bridge never blocks its ports. So as of right now, this switch, switch 2, is our root, and that's why it makes sense that this link over here ended up being blocked. Now, when comparing switch 3 and switch 1 must have an older MAC address than switch 3 because it blocked its side of the connection. Let me show you what I'm talking about. I'll jump over to switch 3 and do a show spanning tree. And you can see, from switch 3's perspective, it's like, hey, everything's great. Root port, we've got designated ports all down here. This is what I was talking about in the previous video, that sometimes it's difficult to determine who's blocking their interface because from switch 3's end of the picture, it's saying, hey, I'm great, because only switch 1 has blocked its interface. Okay, so that's the idea. We've verified that spanning tree is operating. It's not operating efficiency because the wrong switch got elected as the root. So how do we change that? Let me show you the one major command of spanning tree. If you want to run nothing but standard spanning tree, this is the only command that you'll need. However, in modern times, most people will apply some of the spanning tree enhancements that we'll talk about in the next video. But this is it. We want switch 1 to be our root, right? So I'm going to go up to switch 1. Let's do a show spanning tree there one more time, just to verify that as of right now we have somebody else is the root, and we know that is currently switch 2. So I'm going to go into global config mode and type in spanning tree followed by VLAN 1 because we're modifying spanning tree for VLAN 1. Everything in this network is running VLAN 1 as of right now. So spanning tree VLAN 1, I'll hit the question mark. The key that I'm looking for, well, I can do it one of two ways. I can type in root space and then choose my primary or secondary. If I type in primary, it will lower my switch priority to the IEEE recommended value. The IEEE is the standards body who created spanning tree. They're going to set it to a recommended value that they say should be the primary root. The secondary root could be a backup. For instance, if I had 2 core switches or 2 major switches in my network that I wanted to be redundant for each other, I could set the secondary one as a backup for VLAN 1. So I'll show you the other method in just a second, but let's go back and do a show spanning tree and hit enter and notice what happened. The priority, not the MAC address, the priority on my switch was decreased. It went down to 24,577. Again, there's that nice dart on the dartboard, right? And just, that's a good recommendation. So that is below the 32,769 that everything else is in the network. So immediately this switch now becomes the root. Notice we have designated ports on every single one. All of them are forwarding except for the one that was blocked. It's currently in a state of learning. If I hit the up arrow again, now you can see it's forwarding. I'm actually going to show you what all these states are in just a moment too. So this is now the root, which means the switch 2 over here, let's adjust our diagram. This is now the root. Switch 2 must have been bumped down, so let's hop over to switch 2, do a show spanning tree. And sure enough, you can see switch 2 is no longer the root. It's pointing to the root bridge, which has that better priority right there, which is currently switch 1. Notice its ports. It has 1 root port, 2 designated ports. So just guessing, well, very, very confident guessing, I can say that switch 3 must have blocked that interface, fast Ethernet 0/24 on that side, because since this one has all forwarding ports, there has to be a blocked port in the network, so switch 3 must have been it. And you can see it right there. Fast Ethernet 0/24 is currently in a blocked state. So that is setting the root bridge to switch 1, and that's what you want to do in any one of your networks. Spanning tree is so easy to forget about. You get involved in all kinds of, complex configurations, and you're setting things up and things aren't working, and you're working through the night on this brand new network, and you get everything set up and you're like, I'm going home. And you forget all about spanning tree. It's one command. But if you forget it, the network will never really run as well as it could because it's not going to be set up using the most efficient root bridge possible, and it'll just be running slow. And sure, everybody's going to get used to it, and they're going to be like, well, I guess the network is just that slow, and life goes on, not realizing all along that you could have a much faster network if you would just have the root bridge set correctly. Now let me show you the other way to do it. That was using a handy keyword, which was the spanning tree VLAN 1 root primary. The other way that you can set the root bridge is to type in spanning tree VLAN 1 and set the priority. This will manually allow you to type in the priority of spanning tree, which this is the value right here that it came up for us with when we went in and typed in the primary. So notice right here it's saying you can use any value from 0, where 0 is obviously the best, all the way up to 61,440, but you have to use increments of 4,096. I don't know. I know you're thinking, why did they do it that way? Just because they did. So that is the range of the priorities that you can have, all in increments of 4,096. So you could use 0, 4,096, 8,192, and just keep adding 4,096 to find out all the different values. So if you wanted to, you could actually set it down to 0 to make sure that this one always becomes the root. By the way, that is a known hacking method. I should mention this. You can set up, so let's say this guy in his cubicle is a very angry person who wants to try and destroy your network. He could plug a managed switch, meaning a high-end switch, into the network cubicle wall jack and type in spanning tree VLAN 1 priority 0 to where his switch becomes the root bridge. And then everybody points to that cubicle as the center of the network, and the whole thing just starts going really slow because it's going through a cubicle wall jack to do most of its connectivity. So there are actually methods out there that you can put in. It's actually known as root guard and BPDU guard and things like that. Those are security systems that you can turn on that if somebody plugs in an unauthorized switch that tries to do that, it will shut their port right down. Ha, take that. All right, so we've got the root bridge set up. Now I want to show you a failover. Actually, let's jump back to the topology here. I'm going to show you what I'm going to do. As of right now, we've determined that switch 1 is the root bridge because that's what we set it to. This port and this port are forwarding. This link is blocked. It's set as the backup connection should any one of those links fail that Spanning Tree is managing. So here's what I want to do. I want to initiate a ping, a continual ping from, let's see, I'm sitting on this PC right now, so I'll do a ping from this PC to this PC that's constantly going. Once that ping is going, I'm going to disable, we'll just say this link right here, shut it down, so that it is no longer operational. I want to see how long Spanning Tree takes to detect that problem and then activate this switch link. You ready to watch? Here we go. Let me bring up the command prompt first. And I'm going to type in ping. Actually, let me just verify which one I'm on. ipconfig. This is, let me just scroll back up, the 192.168.1.50 PC, which is the smiling PC down here. And I'm going to shrink his window down about that big so we can have the config window at the same time. And I'm going to type in ping 192.168.1.20-T, which is a repetitive ping, meaning it's going to go nonstop. It's just going to keep on pinging. All right. So that's going where we're now actively pinging that workstation. Let me bring up, actually slide it up here, this configuration window, which is switch 1. Now let's see if I can still see my network diagram. Switch 1 is, I'm going to shut down Fast Ethernet 0/12, which will disable the active link that's currently working for Spanning Tree. I'm going to keep these both in the window right here. So let me go into Interface Fast Ethernet 0/12 and do a shutdown. All right, it is shut down. The pings have now stopped. Notice the connection's timing out below. I'm going to, let me just hop on over to switch 3. I'm going to do a show Spanning Tree right now. Notice oops. Notice what mode. I don't know if you caught that before. It was in, look at this, we're down. The network's down right now. It was in listening mode on that backup port. Then it went to learning mode. And look at that, wham, we're now back online. The switch is pinging. Now, that was, I'm sure, you know, with my kind of banter, talking, and so on, that was about 30 to 50 seconds of a network outage that occurred just to allow Spanning Tree to fail over. Now, that may sound like, okay, that's, no worries, life is good. But remember, our networks nowadays are running connections like voice over IP. You have phones running on the network. You have active file transfers. You have replications. You have airline schedules. You have credit card transactions. You have stock quotes. All of this stuff is happening real time. Snap, 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 snap. Flying across your network. If you have a network outage of 2 seconds, that's something where people are like, whoa, what just happened? Phone calls drop everywhere. Stock quotes get kind of, off and off shift. If you go for 30 to 50 seconds, and let me revise my excitedness here, 30 to 50 seconds in a production network, in a critical business network, you're going to have a major crisis on your hands. What I just demonstrated is why Spanning Tree, as it stands right now, is not used very often in full enterprise networks. There's enhanced versions of it that we use. Matter of fact, watch this. I'm going to go, let's see, back onto switch 1 under Fast Ethernet 0/12 and do a no shutdown. Let's power that guy back on. Yay, we'll fix everything, right? What it's going to do is, as soon as all the links are detected and back online, notice, you see my equal signs? They've stopped. The network has gone down again. I'm serious. I'm going to do a show Spanning Tree. Look at this. Fast Ethernet 0/12 has gone into its nice little listening state there. Let's do a Spanning Tree. Oh, now it's learning. Meanwhile, imagine people right now going, ha, ha, network down, phone calls dropping, customer dissatisfaction, airlines are out of whack, credit cards aren't being processed. Ah, see, I'm trying to hype this up here. There's a major network outage, and finally, we're still dying here. Well, it looks like the port is forwarding, but something still hasn't come back online. This is actually known as a blocking timer. Eventually, give it 60 seconds, give it a minute and a half or so. Eventually, it will renegotiate and the port will come back online and go active. Spanning Tree, the version that we just saw, Was developed a long time ago. I mean, think when switches came out, that's when spanning tree came with it because people wanted redundant connection. So we're talking a technology that a decade ago, it wasn't that big of a deal to have an outage of 30 seconds. That's all right. But nowadays we have to use enhanced versions. So there it is, basic spanning tree protocol. Essentially a protocol that is necessary in our networks, but needs to be enhanced and upgraded, as we just saw. So what we first off looked at was enhancing our network diagram by adding in a redundant link between the two switches, which spanning tree did its job. It identified it and it blocked it. So we identified the current spanning tree configuration, which just the oldest switch that you have in your network will be elected as the root bridge, and all the switches will find the best way to reach that root bridge and then block all the redundant connections. So what we need to do is find the best switch in our network, even in the enhanced version. I don't mean to hype up the enhanced version like everything's better, everything's changed, although it is a lot better. But in the enhanced version, we still have to elect a root bridge. We still have to make sure that we have, all the core technology of spanning tree, even in the enhanced versions, is the same. So we have to configure a root bridge and set that up as the core of our network, and all the switches will find the best way to the center and work from there. I hope this has been informative for you, and I'd like to thank you for viewing.